All right, let's jump right into it. Welcome to this explainer, where we're going to unpack a super fascinating concept from the world of computer science known as the greedy algorithm. Now, I absolutely love this topic, mainly because it takes something that sounds incredibly dense, algorithmic optimization, and it just boils it down to a surprisingly simple, almost human way of making decisions. By the end of this, we're going to see exactly how this one specific strategy bridges the gap between, say, planning your next big vacation and how your computer miraculously shrinks down those massive files. So let's get into it.
To really wrap our heads around how this works, we need a good, relatable analogy. So, picture this. You are planning an epic road trip. You're starting out at City A, and your final destination is City E. But there's a catch. You absolutely have to make stops at Cities B, C, and D along the way. Naturally, you want to get to City E as fast as humanly possible, right? You're looking for the absolute fastest, most optimized route for the entire journey.
Now, the most obvious way to guarantee you find the absolute fastest trip is to just check every single possible combination. You could sit down with a map, write out every permutation of routes between all these cities, add up all the driving minutes, and then compare them all. But, think about the sheer number of overlapping lines and time calculations involved there. That approach quickly becomes a massive headache. Checking every single route to find the absolute least amount of driving time is just overwhelmingly complex and, honestly, a huge time sink.
Which leads us to a really practical problem. And frankly, exactly the kind of problem computer scientists completely geek out over. How do we actually optimize this journey, finding a remarkably fast route, without having to sit down and agonize over every single possible path? Like, is there a shortcut we can take that gets us a great result without all that heavy math?
Well, instead of trying to map out the entire multi-city journey all at once, the solution is to literally just look at your immediate options. Standing in City A, you simply take the single shortest leg available for your very next step. Then, when you get to that next city, you just do it again. Pick the fastest route to the next stop. You take the route with the shortest duration at each individual leg. You're effectively making a series of immediate, isolated choices, trusting that this really straightforward strategy is going to result in a very quick overall journey.
So, in the formal world of computer science, this exact road trip strategy is what we call a greedy algorithm. And the whole thing hinges entirely on something known as the greedy choice property. This property basically states that you can arrive at the best overall solution, which the experts call the global optimum, simply by making the absolute best possible decision at each individual step. That's your local optimum. You don't actually need a master plan from the very beginning. You just need to grab the best choice sitting right in front of you over and over again.
The really crucial thing to understand here is how this algorithm actually behaves in the wild, because it operates with some pretty strict constraints. First off, every single decision is based purely on the current context. It's like it has total blinders on. Second, and this is kind of wild when you really think about it, it completely ignores the impact of that choice on any future steps. It literally doesn't care if picking the fastest road right now leaves you stuck with a terrible road later on. It just grabs the best option available at this exact second. And finally, this process just continues, relentlessly step by step, until it hits a final solution. It is incredibly single-minded.
Okay, let's zoom out for a second and see how this fits into the broader landscape of algorithms. You're very often going to hear greedy algorithms mentioned in the same breath as another absolute heavy hitter in computer science, dynamic programming, or DP for short. Both of these approaches are the go-to tools for solving optimization problems. And they're related because they both rely on checking to see if a problem has an optimal substructure. That's just a fancy way of saying a big, gnarly problem can be successfully broken down and solved by looking at smaller subproblems.
But here is where their strategies drastically, completely diverge. While they both break problems down, their decision-making process couldn't be more different. As we know, the greedy approach follows that greedy choice property, grabbing the best immediate local option without ever looking ahead. Dynamic programming, on the other hand, it's the meticulous over-planner. DP considers absolutely all possible solutions to guarantee it finds the true global optimum. It's doing all that heavy lifting of checking every confusing map route, while our greedy algorithm is just cheerfully pointing the car down the fastest street right in front of it.
Because dynamic programming is so incredibly thorough, it's generally true that any problem you can solve with a greedy algorithm, you can also solve using DP. It covers all the bases. But, and this is a really big but, the reverse is definitely not true. Not all DP problems can be solved using a greedy approach. Why? Well, sometimes, if you only look at the immediate best option, you actually end up painted into a corner, trapped in a really bad overall outcome. The greedy approach really only works when the specific nature of the problem allows those small, short-sighted choices to successfully snowball into a great big picture. Now, you might be sitting there wondering, okay, why does this actually matter? If this algorithm is so short-sighted, where does this kind of tunnel vision approach actually show up in our everyday digital lives? Well, the answer is literally everywhere. It turns out that this fast, super efficient way of making decisions is an absolute superpower when it comes to one of the most vital functions on your computer, and that is data compression.
And that brings us to a truly ingenious real-world application known as Huffman coding. Huffman coding is a brilliant algorithm used specifically in data compression. Its entire goal is to take your input characters, the letters and symbols in a file, and assign them variable length codes based purely on how frequently they appear. The clever twist? The most frequent characters get the absolute shortest codes. The ultimate big picture goal here is to minimize the overall size of the encoded data. It's a classic optimization problem, and it turns out it's absolutely perfect for a greedy approach.
Let's break down exactly how Huffman coding uses this greedy strategy step by step. First, it scans a file and identifies the exact frequency of all the characters. Then, it makes its classic greedy move. It always grabs and combines the two least frequent characters first. That is its local optimum, the best, most obvious immediate choice it can make right then and there. It doesn't look ahead at the rest of the file at all. It just keeps repeating this single step. By continually taking the two smallest remaining pieces and combining them, it guarantees that the overall size of the final encoding, our global optimum, is shrunk down as much as physically possible.
And the results of this seemingly simple step-by-step optimization are just staggering. I mean, this isn't just some abstract theory. This exact greedy method is incredibly effective and is widely used right now, probably on the device you're watching this on, in file formats you interact with every single day. When you compress a big folder into a zip file to email it, or when you save a photo on your phone as a JPEG, you are directly relying on the crazy efficiency of algorithms like Huffman coding, built entirely on the backbone of that greedy choice property.
It's genuinely fascinating how a concept built entirely on making the most immediate, almost totally short-sighted choice can lead to such globally optimal, powerful results in our technology. Which kind of leads me with a thought I want to pass on to you. Beyond the realm of algorithms and computer science, think about your own daily decision-making. Where else in your life are you making greedy choices? Optimizing solely for the immediate step right in front of you while completely ignoring the future. And more importantly, is it actually leading you to your true global optimum? Thanks so much for joining me on this explainer. I really hope it sparks some curiosity for you today.